Hello, and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of the Pythagorean Theorem, specifically how we could use it to find the distance of 2 points on a coordinate plane, and we'll do it in 5 minutes or less. So ever since we started graphing on the coordinate plane in the 5th grade, one thing has eluded us, is telling us how long one of these diagonal lines are. We know how long lines are if they're exactly vertical or horizontal. But let's say we've got a line here. I'm just going to label it AB. So this line segment AB, we don't know the distance because it's diagonal and it kind of cuts across lines. We can guesstimate, but it's not really exactly what we're wanting. Well, now we can actually use the Pythagorean theorem to get the answer. So what we could do here is if we think of this as the hypotenuse, that's the one trick that we need to come up with. Think of that as the hypotenuse. Once you think of that as your hypotenuse, well, now we can turn this into a right triangle. Any slanted line, as long as it's straight, we could turn into a right triangle. So I'm going to kind of connect it there, connect it there. I'll label that point C, but look what I've got here. I have got a right angle, so I know my Pythagorean theorem lets me know that a squared plus b squared equals c squared. Really, those are just talking about the legs. So if you square the legs of this right triangle and you add them together, you can find the square of the hypotenuse right there. So here's one leg. I've got this BC. So if we take this BC and you square it, and then you've got this AC, that's my other leg, you square it, you are going to get that AB squared, and then we've got to find the square root. So BC is got a length of 3, so 3 squared. AC, let's see, it's got 1, 2, 3, 4, 5 squared, so that's going to be 25, equals my AB squared. So that's going to be 9 plus 25 equals AB squared. So that's going to be 34 equals AB squared. And so in order to figure that out, the last step is we've got to take the square root of both. That's going to give me just AB. If we had a calculator, we can find it exactly, but we can say 34, right? 34 is really close to 36. That's 6 squared. The next one below is 5 squared. That's 25. That's not that close, so I'm going to call that maybe, let's just estimate that 5.8. So we can say AB is about 5.8. We can use a calculator to get exactly. That's how you can use it. And it doesn't matter whether it's just in one quadrant. You can even go into multiple quadrants. So let's see what happens if we do one over here. It's going to be kind of a long, shallow line. And even though it's a long, shallow line, we still can use our Pythagorean theorem. So let's just go ahead and label this as DE. It's long and shallow, but let's go ahead and make it a right triangle. Take that line, make it a right triangle. And then we're good to go. Let's label this F. So we have FD squared plus FE squared. It's going to equal my hypotenuse right here. It's my hypotenuse DE squared. So DF squared is 1, 2, 3, 4, 5, 6 squared. Now my FE squared is easy. That's 1. And that's going to be DE squared. So that's going to be 36 plus 1. See how we just keep using the same Pythagorean theorem again and again and again, equals DE squared. So look at that. That's 37. 37 equals DE squared. Have to take the square root of both. Once again, if we have a calculator, we'll figure that out, but look at that. You know that 37 is really just close to that 36, which is 6 squared. That next one, 7 squared, is 49. So that's probably going to be around 6.1. So we could probably say that DE is approximately 6.1. Take out your calculator, double check my work. But anyways, that's how we use the Pythagorean theorem to find the distance of diagonal lines on the coordinate plane.